All right, so let's go ahead and get started with a quick review about the Trig's functions we've talked about so far. So the first two we learned about were sine and cosine. Those were the two basics that all the others are built on, and there are four more trig functions that are combinations of these. We have four more. So who can give me one of the other four trig functions? Give me a name. Nice and loud. Tangent, very good. It's usually the third one you learn about in Math 2 when you start talking about right triangle trig. And we know tan is sine over cos. Very good. Three more. Who's going to give me another one? Someone other than Jaylee. Cotangent, very good. We know cotangent is 1 over, ooh, that is the worst fraction I've ever drawn. 1 over tangent or cos over sine. Very good. Two more. Tony? Secant. Very good. We know that secant is 1 over cos. And our last one, what's the one that's missing up there? Cosecant. Very good. Cosecant. CSC is the inverse of sine, 1 over sine. Perfect. 6 trig functions. 2 basics, the other 4 that are based on those 2. Yeah. And we were using what we knew about sine and cosine to find the other 4 trig functions, and we're going to pick up with 2 more examples. When we did examples together on Friday, I gave you a point on the unit circle. And we know that points on the unit circle are cosine comma sine, meaning I already knew the value for those 2. Now we're going to do some examples where I have an angle and I don't have any of the trig functions. Yeah. So we're going back to finding trig functions, and I think we should be on example 3, if I'm not totally losing my mind. And for example 3, I know my angle T is equal to pi over 6. And I want to find all 6 trig functions for the angle pi over 6. We're going to do them in the same order that we did on Friday. Right? Start with sine of t and cos of t. Then we find tangent, and then we find their reciprocals. Yeah. And instead of writing t in there, I know what t is. T is pi over 6. And this is going to be a bit of a throwback, but pi over 6 is one of those angles that's in the picture of the unit circle. That's a really common angle measure that pops up. So you're going to need to flip back to your 5.2 notes. And in your 5.2 notes, there was that first quadrant picture of the unit circle. And we want to know what sine and cos are for pi over 6. So what was the first one? Ooh, I think that's pi over 4. Root 3 over 2, good. And that's the x-coordinate, so that would be cosine. What is the y-coordinate that goes with that root 3 over 2? 1/2. Very good. So sine must be 1/2. Very good. And if I know my sine and my cos, I can find my tangent, because tangent is sine divided by cosine. So sine is 1/2. Cosine is root 3 over 2. We change that to a multiplication problem. Yeah. So numerator times reciprocal of the denominator. What does a reciprocal of a fraction look like? Flip it. Yeah, very good. We flip it. So instead of root 3 on top, it's going to be 2 on top, root 3 on bottom. And what do we see? Cancel out the 2's. When we're calculating tangent, those denominators are going to be the same. The denominators are going to cancel. It's going to be the numerator for sine on top and the numerator for cosine on bottom. So this is 1 over root 3. Do I leave it like that? No, frowny face. We rationalize it. How do I rationalize it? Good. I'm going to multiply it by something. What am I going to multiply it by? Very good. Multiply it by the radical on bottom. Perfect. So root 3, come on, pen, on top, and square root of 3 times square root of 3 is what? It's just 3 itself, yeah. Yeah. Happy face. And this is going to look a lot like example 1, but with some sign changes. Because if I look at my sine and my cos, they look almost exactly like my sine and my cos for number 1, but there's a missing negative sign. Yeah. Okay, next trig function. We'll start with secant, which is 1 over cosine. So 1 over the square root of 3 over 2. So the reciprocal of square root of 3 over 2, which you guys told me in the last problem is 2 over root 3. Arturo, what makes me unhappy in that fraction? We got to what am I multiplying by? Very good. Rationalize the denominator. Perfect. So 2 times root 3 over 3. Happy face. Happy face, happy face. And the last two will be a little less scary. Next one is cosecant, which is 1 over sine. Yes? And my sine is 1/2. What is the reciprocal of 1/2? 2 over 1, which is 2. Yeah. Perfect. Perfect. Yes, Arthur. Where? Oh, that's not an angle sign. That is a horribly messy 2, because I'm running on like 0 hours of sleep. Thank you for pointing that out. Yeah. Right, because we had the 2 with here, and then we multiplied it. Okay. LG, what's my last trig function? What's missing up there? Cotan, very good. I'm going to do cot. Cot is sine. No, cot is the reciprocal of tangent. So the reciprocal of sine over cos is cos over sine. So cos is root 3 over 2. Sine is 1 over 2. Yeah, looks like tangent, but upside down. Numerator times reciprocal of denominator. And Julius, what happens to that? You don't know. I see something that cancels. What cancels? The 2, yeah. 2 on top, 2 on bottom. So we get root 3 over 1, which is just root 3. Happy face. Yes. Ooh, okay. So here, and we see the same pattern here. When you have 1 over a fraction, that's a reciprocal. 1 over something means reciprocal. So I need to flip that. If you don't recognize that pattern, that 1 over a fraction means reciprocal, we could do what we did here. Because this is 1 over 1 over 3 over root 2. And we know we take the numerator and we multiply it by the reciprocal of the denominator. Yeah, and then it just takes you right there. That was a good question. Yeah. So if you've got 1 over a fraction, it's saying take the reciprocal in a convoluted way. Reminders that all of these over here are reciprocals of something over here. So to get secant, cosecant, cotangent, we should be flipping something. Right? Secant is the reciprocal of cosine. I should be flipping my cosine fraction. Right? Cosecant is the reciprocal of sine. I should be flipping my sine function. Cotangent is the reciprocal of tangent. I should be flipping my tangent. That one's less obvious because we rationalized, but before we rationalized, that reciprocal is really clear. Okay, do we want to try one more or do we want to move forward? Was that a one more or a move forward? What was that? One more? Okay, I'm going to pop one that's very similar to this on the board. I'm going to give you a couple minutes in your small group to get it started, and I'm going to call on people for help to walk me through it. Yeah? Okay. Same process. I'm going to give you an angle measure. So this time we want our angle to be pi over 3. Pi over 3. T is pi over 3. I want you to find the value of all 6 trig functions at pi over 3. Yeah. A couple minutes in your small groups. I'm going to call on some people to help me with it. You got this, Jules. Ooh, I see lots of people with their unit circle out. Very good. So reverse those. So tangent would be that on top. That's perfect. You got it. Okay, so we know our angle is pi over 3. We want to know the 6 trig functions. First thing we do is find sine and cos. Olivia, what did you get for sine? Square root of 3 over 2. And what did you get for cosine? 1/2. Can I get a thumbs up if you also got those values? Very good. These sit on either side of 45 where x and y are equal. So these just switch x and y. And if we zoom out a little bit and scroll up, you'll notice all we've done from the last example to this example is switched sine and cos. So the question is, what's going to happen to our other answers if we switch the sine and cosine values? So I expect there's going to be a relationship between these 4 answers and the answers I saw in the last one. Okay, Natalie, what did you get for tangent? Square root of 3? Can I get a thumbs up if you also got square root of 3? Very good. Where did we see square root of 3 as an answer in the previous example? Cotangent. These guys switched when these guys switched. Yeah. Which means if I know that my tangent and my cotangent switched, this is probably what my tangent was before, which was this. Did anybody get that as their answer for cotangent? Is it root 3 over 3? That's right. The 2 comes up somewhere else. Just that? Yeah. Let's scroll back and check. Yeah, that's what we got for tangent last time. Yay. Okay, secant. What did we get for secant? Ray, what did you get for secant? Secant is 1 over 2. Did anybody else get 1 over 2? I'm not getting a thumbs up. What else did we get? Natalia, what did you get? 2 over, so 2 over 1. We had that right, but we need to flip it upside down. Good. And Abner, what did you get for cosecant? I see some nodding. And notice if you look back at the previous example, those 2 are likely flipped from what they were in the last example. So when we switch sine and cosine, we switch tan and cotan, and we switch secant, cosecant. Switching these 2 switches the other 2 pairs as well. And if you can remember that pattern, that's going to save you time evaluating those 6 functions. Yay. Okay. One last fact, and then we'll be done for the day. Yeah. So way back in pre-cal, your favorite class ever, I'm sure, we talked about the concept of even and odd functions. Even versus odd. Even versus odd. And we talked about it in terms of a graph, an even function. For example, we have a parabola. Parabola is an even function. That's that U shape, right? And we know you can take that U and you can flip it in half and you get two perfect mirror images. Yeah. Odd, right? You flipped it and then flipped it again. Like the x cubed graph. Flip it and then flip it again and you get the same picture. And all of our trig functions fall in one of those two categories. Yeah. And I have to remember, I wrote it down. So cosine, and I can totally write here, secant, which is the reciprocal of cosine, are even functions. So when we graph them, we expect that they're going to form two perfect mirror images that fold onto each other. We're going to look at the graphs next week. We also know that f of negative x is the same as f of positive x. That's what it means when we flip about the y-axis. Positive x and negative x give you the same y value, the same answer. The other four are all odd functions. So the missing four, we're missing sine and tangent, and we're missing their reciprocals. So the reciprocal of sine is cosecant, and the reciprocal of tangent is cotangent. Those guys are odd functions. Meaning if we look at their graph, they reflect through the origin. We have to flip them up and then flip them over to get that mirror image. They flip twice. That also means if I take that function and I give it a negative input, it's going to change the sign on the y value too. Negative x gives me negative y, or negative f of x. So for cosine and its buddy secant, if I shove in negative pi over 3, it's going to give me the same answer as pi over 3. For all of the other trig functions, sine, tangent, and their buddies, if I shove in negative pi over 3, it's going to take the answer for pi over 3 and spit out its negative. Meaning you change the sign on the x, you also change the sign on the y. Takes you from first quadrant to third quadrant. Yeah? And we're going to practice when I see you tomorrow using those rules to find values for some trig functions really quick. And then we're going to talk about what happens to that Pythagorean identity, sine squared plus cos squared equals 1, for these new trig functions. Tan, secant, cosecant, to cotangent. Yeah? Okay. A reminder, I'm going to pop back up our homework.